Hi, Travis. Very happy to have you on our podcast today.
Hey Max, nice to meet you. Yeah, very happy to be here as well.
Awesome. Yeah, going to be a super interesting talk for the next half hour. For the people who don't know you yet, do you maybe want to lose a few words about yourself, the company, and the ecosystem you're currently in?
Yeah, absolutely. So I'm Travis Scott, the real Travis Scott. Um, I work at Finetech, which is a small German company here in Berlin, just outside of Berlin city center. And we make uh, die bonding, die packaging, and die assembly equipment for the back end of the semiconductor market. So what that means is we make machines that are extremely accurate. So we can pick and place extremely small or large components with very, very phenomenal accuracy.
Uh-huh.
And then bonding these components together, we can use almost any bonding technology that's on the market today and control all of this with extreme accuracy and precision. And that's what brings us into a lot of very cutting edge R&D and cutting edge product development.
Yeah.
Um, and at Finetech, I'm working in business development and product management. But I come from a background of service and application. So that's like working with customers to solve their problems on the machine or with the actual processes and products.
Yeah. Awesome. Super interesting. I mean, the semiconductor market is one that's especially hot since a few years now. Is it also a shift that you can feel in the company that the external demand is super, super high right now and it's a hot topic?
It's interesting because with us, it just kind of cycles around what's end product is getting very big. So for some time, it was like optical transceivers for database communication and everything. That was and is still a very big part of the market. But what we're starting to see growing now is like a lot of quantum technologies.
Yeah.
Um, and yeah, just it's a kind of cyclical market. So a lot of people say that the semiconductor market kind of raises and drops every 3 to 5 years. So I guess we're kind of in a slower period at the moment.
Okay. Oh, that's super interesting. Also a bit contrary to what big media is like telling everyone about the market at the moment. Cool.
Yeah, I mean,
Mm.
it's an enormous amount of uh, value. There's a lot of money moving around in the semiconductor market.
Yeah.
But I think everybody's aware of this funding that's happening at the moment. It's like circular funding in the AI industry.
Yeah.
So everybody's just paying into each other's pockets. So there's definitely some interesting finance happening in different parts of the industry.
Yeah. Let's call it interesting, but yeah, it's a cool model. It's a cool model. In my research, I've also saw that like you're in Berlin, but like you also worked across the US, Europe, Asia a bit. Can you tell us a bit about like how that actually has shaped your view on how innovation scales globally or is used globally?
Yeah, so I've worked at Finetech for 7 years, and I would say probably about one quarter of that has been outside of Berlin or outside of Europe as a whole. So I've spent quite a lot of time in Thailand, across Asia, so Taiwan, China, South Korea, and then also a lot in the United States from west to east coast. And it's very interesting because as far apart as they are, they're generally very interconnected. So like a very large American company might buy a small niche specialist technology company in the Middle East.
Yeah.
And then they offshore their production to Thailand. So you sit in a meeting across, 5, 6 different time zones. You're sitting in a room full of Thai people with some people from Israel or some people from the United States all in the same call.
Yeah.
And yeah, communication is a very big part of that. So patience, communication, trying to get everything in one place. So it's very interesting that the world is becoming so global
Hmm.
in that sense. And I was doing this quite a lot before COVID. And in COVID, like people were flying from all over the world to get to these production places to address, problems on the ground, all these challenges that were coming up. But what I see now is that there's a lot of team viewer, there's a lot of teams. So like it's definitely become a lot more accessible and cheap to solve these problems than always having someone on site. Uh, but yeah, I think there's still always a need to get out there and get some hands on and see what's really happening in some cases.
Do you think that's a positive development that most of the problems can be solved via team viewer at the moment and you don't need to fly there in person anymore?
Absolutely. So for many reasons, like for the ecosystem, it's great that someone's not flying, 14 hours for a 2-hour meeting and looking at some process running. So that's really
Yeah.
great. And also, I guess for people themselves, like a lot of people that you work with in the industry are generally a little bit more mature by the time they get to the positions that they're in, and they have families and that kind of thing, and they don't necessarily want to spend, 1 or 2 weeks in Thailand. Even though it sounds fantastic, I can tell you a lot of the time you're in the middle of nowhere in a hotel very far away from anything fancy with beaches or anything like that.
Yeah. I can imagine. I know that very well myself. Like it always sounds like holiday, but it's absolutely the absolute opposite. Just because you're in a nice country doesn't mean you see the nice places.
Yeah. But it's also
Absolutely.
like, it's really cool. So you see a different side of life. Like you get to, you know, go to a country and you work with people from that country. You have lunch with them, dinner. You kind of do their daily commute to and from work with them. And you live a little bit of someone else's life and you see, what life in that country would look like if you ever decided to live there. So I've
Yeah.
had this quite a lot, especially in Thailand and the United States. So to see what life looks like there, and it's really cool. So you get to have this little slice of somebody else's life for a couple of weeks at a time.
Yeah. Awesome. Very cool. Was there a moment that like first pulled you towards this world of like deep tech and now with the connection to artificial intelligence?
So technology always just kind of came naturally to me. So in high school, or in school and college, all of my subjects just very naturally went to technical subjects because I just found it kind of natural and easy, and I didn't have to do so much homework on the side.
Yeah.
Then getting into college, yeah, it was just a natural progression from the things I was interested in. I went into precision engineering in the very beginning, so like milling machines, lathes for the oil and gas industry, some space, but it was always like very high precision. And the
Hmm.
company I worked at specialized in EDM, electric discharge machining. So this is like one of the
Hmm.
most accurate machining processes you have in terms of like removal processes. Then I worked at a startup for a couple of years, and this was just kind of, I always see it as like my college years. It was just fun, like relaxed, a good time. And then I
Yeah.
came to Finetech. So with Finetech, in the beginning, I was really just looking for something that was in technology, kind of precision technology, but also gave me the opportunity to travel. Uh, and what really hooked me was the customer base. So because our machines are so flexible with so many different modules, and because we have like the highest accuracy of almost all of these bonding types, it means that
Hmm.
like a company, so if a research institute or a university or a company working in deep tech or future tech, if they're trying to build a product, generally they don't know what or how they want to build in the end. So they
Yeah.
would come to us and they ask us, to help them with processes, to help them with parameters, bonding technologies, this kind of thing. But also very generally, they want a machine that can do 3 or 4 different types of bonding technology. And then they want to test all 3 or 4 of these types to see which is the best. And then they have a machine that
Hmm.
can do all of those. And when they settle on the one that they want, they have a machine that can continue that into like a production environment later on as well. So because of this, we have like an absolutely insane customer base. Like I really wish sometimes that I could speak about all the names and things because it's so exciting to talk about who we work with, but generally I can't.
Yeah.
And because of this, I get to go and sit with some of the most amazing product development in the world, like some of the most amazing technologies. And because we're working with the people who are building, first prototypes, first small batch production runs, like you're really seeing that those products developing step by step. So it's
Yeah.
really an amazing place to be.
Awesome. Yeah. Sounds really, really cool. And also can back you up on the amazing customer names as we also had a bit of a talk behind the scenes.
Yeah.
When we look at the intersection of AI and physical systems now, how do you see that artificial intelligence is transforming precision manufacturing and also quantum technologies in the next year or years?
Um, so I've been in AI for quite a long time. So my friend Nicholas, he started the Meetup AI. Um, and I took part from very, very early days. So like kind of co-founder level. And
Mhm.
Meetup AI was founded as this very realistic place, or a very kind of um, positive but realistic talk about AI. So it was at a time where everyone's like, AI is going to steal our jobs, all of this typical rhetoric that you see on the news. And we wanted to kind of open that up to discussion, but with people who work with AI. And some very interesting examples is like radiology. So we had like a radiologist, I think they were working at Charité at the time, and they were on these
Mhm.
like first introductions of AI into radiology. They said, like, what's really great about AI is I used to spend all day looking through a bunch of negative cancer screenings, for example. But now I come in and there's a stack that says this is 100% negative, but check. These are 100% positive, but check. And then these are questionable, and we need a human to go through these things. And they said that it dramatically
Mhm.
reduced their workload throughout the day, and then they could actually go and be a radiologist instead of just screening scans all day. So this is like
Yeah.
one example that really stuck in my mind from the early days of Meetup AI. And what's really weird, this is like almost 8, 9, 10 years ago now. And at Finetech, we now have a VEC student, like a working student for some months, and he's studying applied AI, which is crazy to me that there's now like a full university course of applied AI in industry.
Yeah.
So yeah, at Finetech, we're trying to implement some AI in different processes. So we're trying to use it as like a search base. So we want to collect all of our knowledge into one place and have like a searchable database and a tool where we can try and find information very quickly. Because like all technical companies, and also like you live in Germany and you know how German digitalization works sometimes, it's very, very slow. So it's really cool
Yeah.
to see it at Finetech. But it's, in terms of coming into production machines, into machines becoming autonomous somehow and having some kind of level of intelligence, I definitely don't see it coming in as like a system level, like a machine that can fully run itself. Um, in the At least in the next 5 years or 10 years, I see it coming in like a very modular way. So any system that works on like a touch-based measurement or pattern recognition, AI will
Mhm.
definitely come in there very quickly. So like AI interpreting like visual markers for alignment or uh, visual inspection for defects or any problems like that, that's already happening. And then I see that going into like an automated correction process or error handling. So it will very slowly come out. But I still think like machine setup, process development, all of this will still be a very human process for a long time.
Yeah.
And then also like I'd love to see AI build one of our machines because it takes humans a huge amount of effort and a very long time to do it. So if we can automate any part of that, it would be great. But there's a reason that it takes so long, and it's like a lot of Fingerspitzengefühl. So touch and
Yeah.
feel and everything has to be kind of just right. So to give this to a machine, I think is a very, very long, long way away.
Yeah, I can imagine. Can imagine. Yeah. Fingers crossed for that, though. But sounds like a very
Yeah.
difficult task. I mean, you also talked about like successful initiatives here, also with this knowledge, partner knowledge agent that you have in place. Yet when we talk to companies, we often hear that really many do struggle with bringing digital or AI initiatives from concept to actual production. What do you think is the biggest gap or the biggest reason between innovation and industrialization that you have actually seen?
So I think like what really changed it to become a very fast-paced implementation with us is just getting people who are like truly interested in it. So the
Yeah,
project was started as an initiative, and it's really great. Like it's really great to make a decision to bring AI into a company because it's every company kind of needs to make that decision or understanding if they need it or not. So it was really good foresight at Finetech to do this, to look in and see, do we need AI? Maybe not today, but in 5 years or 10 years time. And this project rolled through, and it kind of, it's like a typical process. It starts, rolls through. But what really gained the speed is we started getting a couple of people who are really interested in AI and really just trying to like get it into something usable, get it into like something that we can implement in small usable ways around the company. So
yeah,
I think a big gap is generally just finding people who are truly passionate about AI. And that's a very big accelerator inside of a company. I think if you give it to like a traditional IT department or something like that, if they're really not passionate about it, it's going to become like a back burner project that always falls to other important priorities and things like that.
Mhm.
Sorry, and what was the second half of the question? It slipped my mind there.
Like the gap between, or like what the reasons you think for the gaps are. But like, I think we can also double down on that because I think it's super interesting. So you think it's more a human and not change management challenge than it is a technical one, actually, to implement those and close this gap between nice ideas, but actually bringing them into production.
Yeah, so I think so I'm really not on the technical side of this AI implementation, and I know there's a lot of like very technical understanding
Yeah.
that has to come in. But I think the world as it is today, like we have so many tools and so much knowledge available to build and support the introduction of these things into systems. And so many systems today are built with this kind of like, API cross communication. So everything should generally just plug into each other very well. And I
Yeah.
think one of the biggest gaps is just having somebody who knows how to bring these two sources together and communicate across those two channels through that, API plug or interface or whatever. And I also think we're in industry today, so in very large companies and kind of deep tech and technology, especially in Europe. So in the United States, they have a much younger workforce in a lot of companies. But I think in Europe, we have a
Yeah.
larger age distribution. And I think
Hmm.
what might play a big role is like in these kind of more senior roles and in these larger organizations, maybe there's not so many like data natives. So people who are born into this kind of like AI software computer interface generation where this stuff comes very naturally.
Yeah.
So I think it could also be down to something like that.
Yeah, it absolutely makes sense. Do you think in like engineering heavy companies that the age distribution is even more on the side leaning towards older people and not younger people?
Generally, so I don't see it so much as a problem. Like it is good to have people who have been around in this
Yeah,
industry for a
definitely.
very long time.
Of course.
Um, and then it's also good to have fresh new people asking questions like, can we do this? Can we do that? And then like they're much more kind of, naive and willing to try something. Whereas like older
Yeah.
generations are like, oh, we've tried that, it doesn't work. And sometimes younger people are like, but I want to find out why it doesn't work myself. So I think it's good to
Yeah.
have this distribution. Um,
Yeah.
and yeah, so it's great to see like AI coming into a 30-year-old German company and starting to creep in and make a change. And it's really interesting to see that happening. And it's cool. Like I'm just generally there to like do some testing and ask some questions and push and pull into this chatbot and this knowledge
Yeah.
base. And just it's at the very beginning. So I'm very excited to see where it goes in the end.
Yeah. Awesome. No, sounds great. I mean, what do you think, in your opinion, are the best ways or some best practices to actually build this AI fluency or like make the people data native if they are not naturally coming from, yeah, uh, from that period where they grew up with it?
So I think easy tool, like very easy to use tools are a very good way to get people up to speed with using AI. Um, in a sense, like I think it's very normal that like a lot of older people are using iPhone instead of Android.
Yeah.
So like I know my
Yeah.
grandmother has an iPhone and just recently she's like, oh, I'm thinking about getting a new phone. Maybe I could get something like yours. And I was like, please just get another iPhone because
Yeah.
it's very easy to interact with. You'd never really have any software issues. It's very kind of clearly laid out. Everything's much more simple. And then even
Mhm.
just switching to a very similar interface like Android, just the differences become a little bit more, open and it gives you a lot more
Yeah.
options. So I think bringing AI into companies that aren't really so prepared for it, or like maybe you have people who have never really worked with ChatGPT and this kind of thing, it's like giving people the chance to just play with it and let it uh, teach them themselves. So we've had this a
Mhm.
few times, like not just in at work in Finetech, but also with like friends and other people where it's like you're talking about ChatGPT and they're like, oh, could you show me how to use ChatGPT? And I always say, download the app and ask it a question and it will show you itself. Like you really don't need so much introduction into it. So I think ChatGPT is a great example of how something like that could be implemented in a company as a knowledge base. But yeah,
Mhm.
so problems to that, like you should definitely work on resource management and localizing data and clean data structures and that kind of thing. But this is also like, as you know, a very typical German thing where there's like old school data storage. And then when
Yeah.
you try to modernize it, everything's like in Excel on a server stored somewhere, like online, offline, and it's really not super accessible for these tools that need to pull enormous amounts of data from somewhere. So yeah, data management and bringing all of this data into
Yeah.
like a more accessible place is a big part of that.
Yeah, I can
But
imagine.
so
So
maybe
you say on the one hand, like, yeah,
yeah, go on,
sorry,
sorry.
do you want to interrupt? Go ahead.
Yeah, so maybe to ask you, because I think this is more like your background, like where do you see a lot of companies struggling with that? Or like what kind of tips would you give to a company like Finetech at this stage where we're just starting to kind of play with this tool and use this kind of tool?
Definitely. So I think, as you said before, learning by doing, I think is always a good place to start, especially if the tools are self-explanatory and you can easily use them. But then on the other hand, we always saw that also it makes sense to think about the use case first and not about the technology. So basically start with what is the actual problem, what do you want to achieve, and then find the fastest or most pragmatic way there. And nowadays that is very often AI, but it can also be not AI, let's say. So I think, yeah, starting from the beginnings, like making your homeworks, looking that the data is somewhat accessible. And maybe that's also some sort of side project in the beginning, unluckily, but it is just the way if you want the AI to work properly, you need to have some sort of data structure that is on a human level understanding, I would say at least. So also a human can look at it and understand what it is. And then, yeah, defining the use case, see what you want to get out of it. And lastly, letting them play around with it and experience the benefits firsthand. I would say that's our way to go about it.
Yeah, so I think this is kind of a, a good example of where we're focusing with this tool. So just to give a kind of broad example, like we have extremely technical projects that come in. So if a customer wants to build a phenomenally difficult product or like with a lot of really difficult challenges inside of it, we start with these kind of feasibility discussions and studies in the very beginning, and we process through, and all of these decisions are kind of, discussed and stored, and reasoning behind it is all distributed somewhere.
Yeah.
Um, and some of these projects happen over years or happened years ago. And trying to find this reasoning, why this tool looks like this, why this work holding looks like that, why certain temperatures in a process were used.
Yeah.
I think this is a great use case to kind of ask a question into the void and get something back and say, like, okay, this temperature was selected because of, certain materials in the product couldn't handle any more, for example.
Yeah.
And another thing we have is in our service department, like it's the same thing. Like service engineer has to fly halfway around the world to fix something maybe very simple, maybe something very complex. And a lot of this is kind of documented or stored. All this information exists somewhere. But for somebody
Yeah.
who's maybe like at the company for 6 months or 1 year, they don't know the fastest thread to get to these places where this information is stored. So what
Yeah.
generally happens is you have to go and ask around, ask a few different people who've been there forever and know this stuff, and just say, "Ah, come on, like it's there, of course, look there." So it's
Yeah.
great to see something coming up that might replace this somehow, and just give you a
Yeah.
very fast thread to the information that you need.
Yeah, cool. So it's also a good tool to basically for onboarding of people, no, and get them up to speed without involvement of resources, basically, I guess.
Yeah. So I don't know, because I also see a little bit of a negative side to that. Like if you speak to a human and you ask a question, they would say, you can use this and this, but be careful because if you, push this button, that thing might happen. So they kind of guide you through a lot of different troubleshooting that happens in the background. So I
Yeah.
definitely think like human interaction will always be there as a part of the process. But yeah, I think accessing knowledge very quickly is one of AI's greatest benefits. So I think this is something we really see as the first goal of implementing it. So to just bring you
Yeah.
very quickly to the information or even just the place where those resources might be stored is
Yeah.
such a benefit at the moment. Yeah.
True. To get some sort of head start. I agree. Do you, coming a bit back to like hardware manufacturing, do you think there are some super underrated opportunities for AI in the space at the moment?
Um, it's very difficult to put it across the whole industry. So maybe some examples like I think more and more machines are going to go down the path of vision-based systems or pattern recognition and this kind of thing. So with
Yeah.
milling machines, milling machines and lathes, you generally have these like touch probes that make contact and store a positioning coordinate. But then in the semiconductor industry and a lot of the electronics industry, it's all based on vision. And
Yeah.
some vision systems can go down to like extremely high accuracy. So like, ASML, KLA, they all work in like nanometer ranges. Our systems work in the hundreds of like some 50 to hundreds of nanometer positioning. So we can recognize something and position it extremely accurately. And I think
Yeah.
AI vision-based systems and positioning and machine control will come in at this level. So I think that's a really great place to focus in and improve on.
Hmm.
And then also maybe data management. So in the semicon industry, there's like SecGen communication, which is like the data management for all of this material that comes through. And then some companies have their own. So we have like a small plugin that works with databases in production and that kind of thing. So it's
Nice.
generally like, if you think about a product that if a PCB first gets populated with like low level products, then it goes along and it gets very accurate parts put on it, like lasers and photodiodes, then lenses, then fiber optics, and then it's a final product, for example. Each of
Yeah.
these processes are tracked in a material management software. So if a PCB ends up at the wrong station and gets scanned with a QR code, for example, it gets kicked out of this process. So it says, I'm not like, you're not supposed to be here. You're supposed to be 2 or 3 processes away.
Hmm.
Um, and implementing and working with these kinds of data management things is very difficult because it's like, it's a lot of information. Each company has its own process flow, its own materials, all of this kind of thing. So I think it also might find its feet there very quickly in the future because it's such an enormous amount of data that has to be handled very efficiently and very accurately. So I think that
Yeah.
might be on the horizon as well.
Okay, interesting. So basically similar to the knowledge tool, the tool that connects with your databases and lets you basically chat with the database and interact with it.
So I don't know if it would touch so much our end. It would probably be on like the other side. So
Yeah.
if you're a small R&D center and stuff like that, you don't really do a lot of data tracking and management because it's done
Mhm.
by like one person building a full product. But when it goes into production, so if you send something to like, you know, China, Thailand, the Philippines, something like that, and you
Mhm.
send like multiple wafers of material and each wafer has its own batch number, and you take a part from this wafer to that PCB and this and this and this, and then you find out that this wafer, like 50% of this wafer failed. You need to be able to go and pull all of those products out of your product line and correct them, change them, something like this. So you need this data management to tie, like 50, you know, 5,000 components to a PCB. That PCB is in your storage or maybe sold to a customer. So you need to be able to cross-check all of this stuff in case one component fails along the line. So that's
Yeah.
just like
Okay.
one example.
Yeah, definitely. Super difficult to manage, I guess, also for humans at this point.
Yeah.
On the flip side of that, do you think there are some misconceptions that people have when they want to try to add AI to physical products or production lines?
Um, yeah, so I think like it's Occam's razor, right? Like the simplest solution is generally the correct one. Like sometimes you really don't need AI. It sounds great. Maybe upper management is like, we need to put AI on something, so we're going to put it here. Uh,
Yeah.
and I think a lot of the time it's probably not needed. Like there's very, very simple solutions to a lot of problems. Um, so I think, yeah, definitely if you're thinking about AI, pick something where it really works well. So AI, like all things, has a huge benefit and it solves problems fantastically in its own way. But there's a lot of
Yeah.
stuff that you can just solve with logic or different tools, different processes that exist out there. Um, yeah, and again, like it's great to have somebody who has a little bit of experience or passion in AI to really understand like what it can and can't do, to work with its limitations or to work with its benefits. So if you can get someone in the company who's kind of on that track and excited about it, that's generally a good way to kind of get a feeling of where it can help and where it can't.
Yeah, definitely. I agree with that. So yeah, again, I think that's also what I tried to say before, like focus on the use case, focus on the problem and how you can solve it. And the technology and how to solve it is probably secondary, I guess. Yeah.
Yeah.
Last question, very tricky one. When you look 10 years in the future, what do you think will be the next innovation that pushes the technological frontier forward in your world?
So I think we're standing today in what was like the 1980s and like 1990s of the internet. So if you went
Yeah.
back to like the 80s, 90s, and you started talking to people about the internet, it was this very abstract thing. A lot of people didn't really understand it. A lot of people didn't touch it or use it in any way. Um, and here we are, like in my mind, 20 years later, but it's actually like 40 years later, I guess. So it's like 2025. And now the
Yeah.
internet is such an intrinsic part of people's lives. Like it's in your pocket. You see it all day, every day. You buy your groceries with it. You buy your household stuff with it. So it just became a part of everybody's life somehow. Um, and I think the technology that we're seeing today at this level is quantum technologies. But I don't think it's going to revolutionize the world in the same way that the internet did. But I think it's going to exponentially expand the internet to beyond what we understand it as today. So a lot of the information that you communicate, even if it's just on your laptop, if it goes to like an Amazon Web Service data center or ChatGPT question, a huge amount of that runs through copper or electronic lines. So electrons are being moved through, stored in registries, shuttled around, that kind of thing. So all this data is happening in an electronic system. And then at some point it gets transferred to optical. So it goes through a laser, goes through a glass fiber, maybe to your router at home or through a data center from database to database, that kind of thing. And the whole industry is trying to pull these optical systems closer and closer to the working side of the system. So if you have a GPU, CPU, quantum processor, all these kinds of technologies that are dealing with enormous amounts of data, we're trying to get the optics as close as possible to that. And then there's even some companies that are trying to generate or create photonic-based processes. So all the information in that system is working on light. So lasers are producing all of these bits, and these bits are what then create that information and store that information and move it. And there's so many benefits behind it. It's extremely fast. So it's far faster than electrons moving. It's much lower power. It's much lower temperature. You get better distances and losses and all this kind of thing. So it's overall a much more beneficial technology. But it comes with the difficulty of building optical systems, which are much harder than traditional electronic systems. So the cost of these systems will go up, the difficulty goes up, all these kinds of things. But eventually they'll just become cheaper, more accessible. They'll be integrated into a lot more technology around us. And then this kind of optical internet will expand beyond what we see it today. And then inside of that, there's like quantum communications. So being able to see the information of a single photon as a bit, instead of like registry buses of electrons and that kind of thing. Just as like a very simple example of that. But I think, yeah, quantum technologies, quantum sensing, key distribution for cryptography, all of these things are going to change the world far beyond what we feel and recognize it today.
Very cool. Yeah, well, the future is bright. Awesome.
Yeah,
Jules,
literally.
thank you a lot. Really was a pleasure. Super cool insights. Yeah, thank you a lot for your time. Thanks a lot for coming on the podcast. And I'm sure people will have enjoyed listening to this.
Yes, thank you very much for the opportunity. I enjoyed it. And yeah, sorry about the technical problems in the beginning, but I think it worked pretty well so far. So yeah, I'm very happy to come on again in the future if you have a spot.
Awesome. Of course, let's do it.